Welcome back to the second part. Now, we said we arrived to our box and we can move back and forth to design extra features that we think could be interesting. So let's just check how it goes. Now, this is our box, the same one we've seen before. At this point on this object, we can do different thing. For instance, we can cut it in two, we can add holes, we can divide all these features and pieces to actually match what we want to do. So let's start with something simple. Let's say we want a hole that goes through the entire object. Now the easier way to do this, at least in Rhino, is to make a cylinder, have the cylinder go through the object where we want it, with the dimension we want, of course. At the moment I just draw it a bit randomly, and do a Boolean difference. So let's have it like this here as well. Okay, so if I do a difference between these two parts and my cylinder, of course, I get a hole that goes exactly through the entire thing. So this hole could be to plug the power, could be to have a button, could be to have a metal bar that goes through it, it doesn't matter. Same thing, let's say that on the top here we want to have I don't know, the output for a small screen. So our small screen could be, I don't know, this side, and it must go through the entire, oh no, let's say it goes through the top surface only, because of course the screen is going to be only on top. Okay, same as before. Difference between this, and we get the hole for the screen. So it's pretty easy to design features this way, and you see this could be controller, or to hold your Arduino inside for interactive projects, or whatever you want. Now, how can we get back the curves to create these objects here? Well, it's pretty simple. In Rhino you can extract curve from objects, and you extract curves in different ways. You have the edge, the borders of a face, the borders of a mesh. If we do this, what we get is actually the curve with the hole that we cut. Now you see that this is not, of course, on zero level, but it's aligned with this face, but it's not a big deal. Same thing if we do it for this, and then we rotate it 90 degrees, we get the same curve we had before. Now I will not go through the entire thing, and I will just take these two curves as an example. So let me temporarily hide this and zoom on this part. So this was aligned here. Okay, as you can see, because the lines matches perfectly, if you have a good laser cutter, you can join the pieces together and eventually take away one of the two lines. Actually, if you join the pieces together like this to optimize the space, you definitely have to take away one of the two lines. To do that, there are different ways, but let's do one thing at a time. So when we are here, what's the problem now? Well, because this hole is not at the center, and this object is definitely not symmetrical anymore, at least not towards this axis, nor this towards this, having everything that is perfectly symmetrical, it's pretty wrong, because the pieces of my box now, let's bring back the box a second. So the pieces of my box, if I take this object and I flip it 180 degrees, it will actually still match pretty well. So if I allow someone to make something and assemble it the wrong way just because the pieces are symmetrical, I'm definitely not helping out here to make things work. Now the holes are not aligned anymore. If I realize that too late, the object will be already glued together, for instance, or assembled, or even if this is flipped as well 180. Now it looks right, but when I put it together with the rest, it's not going to be anymore. So having symmetrical pieces, as we said, is great as far as they are symmetrical. If you have extra features, you definitely have to change this. So let's take the two lines here. It's enough to modify both lines by a certain amount, let's say 10 millimeters, something like this. Now, this line is not symmetrical anymore, and this piece is not symmetrical anymore, but in the wrong way. So I have to modify this line as well to be sure that this cannot be rotated 180 degrees. So this is just to prove that you have to pay attention when you work with parts to help people to assemble the parts as well. But beside that, now here we have our line for the laser cutter, and here we have the second one for the laser cutter. If you want, just to make things easier, you can group them together, but grouping sometimes makes problems with the software of the laser cutter, and we will talk about it in another video. So at the moment, this is what I wanted to show you on this way of making things, but there's still one thing that I think it's important. Now let's take all of this and remove it. As I said, there are different ways to design things. The one we saw was based on 2D, but there are other ways, of course, and it's basically to design things directly in 3D. So this is up to you. I'm not a big fan of this, but in some cases it could be useful, in particular for shapes that are not super easy to draw. At that point, you really have to go and check the match before cutting things. So in this case, what you want to do is to set your construction plane on a single face. In this case, for instance, it's going to be this. Now, whenever I draw a line, okay, I'm drawing on this face. So this is definitely an easier way to go around. At this point, I can design sketching directly on my box. So let's make it a bit faster. Let's say 20,0, then 0,4 the thickness, then again 20,0, and finally 0,-4. Okay, this is the basic module we've seen before. Now the box I made is pretty huge, so it's gonna take a bit, but I just want to show you a detail. So let's finish this line quickly and then skip the rest and get to the point in which we understand how this designing in 3D actually works. Let's see, where's the middle point here? Very close to actually what I did. Okay, that explains why it was that tough to find it. So we said we can explode it, take away the central one, and redraw the final line. Okay, let's pause here and get back with the structure done. Okay, so we finished the face, and that's a pretty basic step. So the face now is completed. We did the line the same way we did it before. So mirroring the thing, getting to the center, keep it symmetrical at the moment. So pretty similar to what we did before. Now the difference is that when you extrude it, and let's say that we want 4 millimeter, but in this direction, of course, what we get on the other side is actually the border that you can use to design on. So if I select this and mirror it, mirror the entire object at this time, still on the midline. Let's say, oh, oopsie. I need to get out from this perspective. Okay, from here it should be easier. Perfect. Okay, now I have my border both here and here. That means, and when I zoom in and when I want to design the line of this object, I don't have to copy and paste and replicate and blah blah. I can just snap my line to the borders. Now I have to be careful to snap it on the right corners, of course. It's easy to, you know, pick up the wrong border or don't match exactly the thing you want to. But on the other hand, this is pretty simple, very hard to make mistakes. Now, just to simplify the process a bit, I will go straight to the next one. Okay, of course, otherwise I would have had to design all the steps and all the connection on that border as well. But in this case, it's just to show you that I can design the thing following each edge of the piece, close my line and have a border that I can extrude. Extrude it, I could actually go and see where and have two pieces that match perfectly. So let's say at the moment we are interested just in these 3 parts, just to don't waste time and drawing everything as we did it before, but you can see the value of using a 3D base to see what's going on. Now you noticed that everything is inside the volume of the object and the edge stays on the border, and this is because we are designing these kind of shapes. In other cases it's gonna be different, but we will see those details in another video probably. Okay, so that's it. It's actually pretty simple, as you've seen. Try out, find out your best way to work or your ideal workflow. Make some simple boxes and then move up to something a bit more complex. The last thing for today is actually to see different ways in which you can use existing softwares to design boxes. That simplifies your life quite a lot. So let's move to the presentation very briefly, or actually just a website I want to show you, and that will be it. The website I was talking about is MakerCase. Amazing website. It allows you to do a lot of different things, starting from the basic box, as we said, the basic starting point of a lot of different designs. So if you click on it, you get this interactive interface with your box in the center that you can rotate and zoom as you wish. We'll work in millimeters because International Metric System That's definitely enough to say. And we set here the dimension of what we want to make. So let's say we want a box that it's 200 millimeters, 150, and maybe 100. So not particularly big. Let's zoom in a bit to see it better. Okay, these dimensions can be both the outside, so the overall dimension of the thing, or the inside. I'd like to keep it on the inside because very often when you measure what you need, it's the volume inside, not the overall shape. Thicknesses, these are pretty standards also because they exist in a similar way in fractions of inches. But we said that we want to work with 4 millimeters, so let's use 4 millimeters. This box is closed, but it could also be open, of course, and then there's top piece removed, and then again we get to the point in which we have to decide the shape of the joints on this piece. So we said never flat. Flat is hard to glue, it's a pain in the ass, complex to make, complex to assemble properly, definitely a no. Very rarely you use flat parts to do things. So much easier this way. Okay, you have the connections and this will simplify the assembling. Now the size of the connections can be changed. Here you have a slider. It gives me a very weird number, I'm not sure why, but you can change it and regulate it the way you want. So I would say, I don't know, 15 millimeters as we designed. So that's it. That's enough to actually get your box. At this point you download the plan to cut it. You get it already with the pieces, divided with a bit of gap, explaining you what goes where, and that's it. It's very, very simple. You could actually get to compensate the curve and have an offset as an automatic thing. Up to you if you want it. As I said, I'm not a big fan of having things that fits perfectly. It's better to leave the laser to take away that small amount of material. That simplifies assembling and gluing, so in the end it's pretty cool. You can choose the colors if you already know the setting of your laser cutter, so which kind of color is used to cut and which kind of color is used to engrave. You can set it up as well. That's it. You have two different formats, SVGs and the XF. We will use the XF, so eventually I suggest you to go for this. Now, we spoke also about screws and T-slots. So these connections here, let me zoom in on one, that allows you to close the piece using bolts. We decide here the dimension of the bolt. So let's say 3 millimeter. It's better if it's a bit longer, let's say 16. So you see we have a bit more material here. Now when you download this, you'll have a square cut here. Last time we spoke about this, the square cut with nothing on this side, on the external side of the piece, allows the bolt to slide out. So that's definitely not what we want. You have no options in here, but when you save the file, you can always, of course, modify it. So we get the plan, we have the basic things done, very almost done, almost complete. We just have to modify few lines here to make it more resistant. So I would say still a good way to go. If we go back to the top, you have other options. these options are pretty cool as well and simplifies your work a lot. So in this case you can have shapes that are not necessary, you know, a box, a square box. Let's say we want it in millimeters, it has the fingers, it picked up a bit of the information probably from the other file. Let's say 200 by 100. Thickness we said custom 4 millimeter. Okay, in this case let's say it's an open one, and the joints, let's keep them 15 millimeters. Now what I want to show you is what we talked about for the joints. When you don't have a square connection, a square piece, so with a perpendicular connection, you always get a bit of a gap. That's okay. You will sandpaper the border eventually, so you will fill the borders. If you have something that keeps the shape, is not a big deal. The joints between the bottom parts and the sides, as you can see, are basically perfect. So there's no problem, it's gonna work anyway. When we go to see the pieces, here we go, 6 sides and bottom. We start to count from 0 because coders do like that. Probably the guy that did the website was a bit of a nerd. Last thing here is this. So there is a way to make plywood flexible. We'll talk about it today. Just want to show you what it looks like, and it's this kind of pattern here. This kind of pattern here allows you to bend something over a round shape. So super useful to have a starting point. This design is not the best, to be honest, but we'll get there and see eventually how to make it more robust in using a proper design. So that's it. This is the end for this video. Try, play out with that, assemble the pieces in 3D, and when you're ready, find a laser cutter and cut your own parts. Bye.